So today we are going to be looking through the practice paper J277, paper 2, so the programming, the computational thinking, algorithms and programming paper. So let's move on to the first question. So here you'll see that we have got, it's another one of those tick box exercises to make sure that you always read if you're ticking more than one box. But this one is a tick one box in each row to identify whether the statement refers to a high-level language or a low-level language. So you have to remember the differences between the high and the low-level languages. High-level languages are written very easily in English words so that programmers can understand them much easier, but one line of code may mean many individual instructions, whereas in low-level languages, more difficult to actually code, but you need to know how the actual physical processor works, and the low-level language works very close to the CPU and the memory, and are only specific to that one processor. So, quickly looking at it, use English-like keywords such as print and while. Okay, there we go. So, first one, nice and easy, it's a high-level language. Must be translated before the processor can execute the code. Now, I think this is a bit of a mean one if I'm honest, because a low-level language is assembly language, and you do need a processor for that, but a translator for that. But if it's telling you to only tick one box, then they're really, by the sounds of things, they're talking about a low-level language being machine code itself, and so therefore must be translated before the processor can execute the code. Absolutely must be, without question, a high-level language. The code written is portable between different processors. Again, that's that idea. Low-level languages are specific to that individual processor. If you think about it, the processor has its own individual instruction set, and each binary instruction is a specific, like 0011, like each binary sequence is a specific instruction, whereas in you can write, apologies for that, whereas in you can write Python or C# or C++ on any processor. It needs to be translated and then it will be ready for that processor. So again, high-level language. Requires the programmer to understand the processor's registers and structure. Okay, all this is telling you here is that, again, that low-level language, again, we're talking about machine code here, but that could also be assembly code, but it absolutely and utterly, the programmer needs to know how the actual CPU, how the memory works to be able to work with that. They need to know what the actual instruction sets are. So that's your first starting question, worth 4 marks. We then move very quickly into the IDE question. Now, quite often the high-level, no-level languages and the IDE questions do come up next to each other. So a translator is a common tool found in an integrated development environment, IDE. Describe 2 other common tools or facilities that an IDE can provide. You should know, really, you should try and think about 3 different tools that the IDE has. So the translator is one of them, having a built-in translator. So you should now be able to say at least another 2, and be careful not to accidentally say the same thing twice. So we've got the source code editor. Remember, we're typing in the actual source code when we're using an IDE. So we're typing in the Python code when we use Replit, for instance, when we've been working in Replit. So we're typing in the source code. So it's the source code editor. And it does say describe, and there are 4 marks here. So give me something that the source code editor allows me to have. And so it has color coding, and auto indentation. Okay, that's one of them. So don't then try and think of another thing that the source code editor does. Try and think of another tool. Now, there are a few tools other than the translator. So the source code editor, and now we can say error diagnostics. You could say a debugger here, that's also fine. And then we have to, again, we're describing it, and so therefore we want to say a feature of that tool, and this is tells the programmer where the error is, as in what line, and what type of error it is. All of you have seen lots and lots of errors as you've been programming yourselves, and you get that red error message and it tells you whether it's a name error or an out of range error or so on. Another one you could have said is the runtime environment, which actually enables the program to run or to check sort of like for errors as it's being run or to test the program. But I would suggest the source code editor and the error diagnostics are two really clear, simple ones to remember there. Right, let's have a look at the next question. Okay, so here we are. This is that structure diagram. It might not look exactly the same as some that we've seen before, but when you see kind of like a hierarchy like this, then it is going to be a structure diagram. You also need to read the question. It does actually point it out in here as well. So make sure you read the question. A school uses a mobile phone app to allow parents to book appointments for parents' evenings. Parents must log in before they can use the system. They then choose to book a new appointment, view all appointments already made, or update their personal details. If parents choose to view their appointments, they can either view them on screen or print them off. A structure diagram has been used to design the mobile phone app. Write one letter from the following table in each space to complete the structure diagram. Now remember, your structure diagram is all about decomposing a problem, breaking it down into its smallest possible parts. Okay, so we've got the mobile phone app, and they've said we need a login system, and the login system is basically then the final, we need to create a login system. So you'll see there's nothing coming out of that one. We've got manage appointments, and then we've got a blank. So what we've got to do here is we've got to go back to the information that they've given us, and it says parents must log in before they can use the system. They then choose to book a new appointment, view all appointments already made, or update their personal details. Well, I would suggest that booking a new appointment and viewing appointments are all about managing appointments. And so therefore the other thing they need to do is update their personal details. And having a look through these, you'll see that C is updating personal details. So let's pop C in there. Okay. What I would also suggest then is actually when we've got manage appointments, we've got view appointments and also book new appointments. And I'm now looking, there we go, there's your book new appointments. So it's all about, they're not asking you to make this up. You have got the information here. What you're doing is logically working through it to see what else needs to be done. So when we're looking at viewing appointments, let's have a look. It says here, if parents choose to view their appointments, they can either view them on screen or print them off. So let's just have a look. Can we see anything? So view appointments on screen, print a paper copy of appointments. And you've got D and you've got F. It does not matter what order you put these in. So you can put D in there, you can put F in there, or you can put it the other way around. The idea is that they are just sub-programs or sub-problems to the viewing appointments problem. And there's your completed structure diagram. You do not need to write the whole thing. It says write one letter into each of the boxes. So that is now that question finished. It's worth 4 marks. So take your time over a question like that, even if you think it looks simple. All of the information is there for you. Work through it logically and carefully. Okay, so we're on our first coding question now. So let's have a read of the question, or the information. At the parents' evening, each parent can book up to 5 appointments with teachers. Appointments for one student are stored in a one-dimensional array with the identifier appointments. In the array, each element is either the name of a teacher or an empty string where no appointment has been made. An example for one student is shown. So we're being told it's an array, and there's the identifier appointments. So we're assigning several. So remember, a 1D array or any array is allowing me to store multiple variables against one identifier. And so in this case, and you'll see the square brackets allow me to see it's an array as well. And you'll see that we've got Miss E, comma, so that's my first element. We then have two empty or two speech marks. So that is basically an empty string. So there's an empty space. So no appointment has been made. Mr. C, comma, Mr. B, comma, and there's another empty space. The following code shows an algorithm to count up how many empty slots remain in the array and output this value. Now, before even looking at this, I know that what it's going to do, and this is what you should be trying to do, is you should be already trying to think about what the code might be. And what you've got to think about is, what we want to do is we want to go through and look to see in the first element, which is appointments 0, and see if it is a blank string. If it's not, then we'll go through and we'll look at the next one, which is appointments 1, and we'll see if that is a blank string. This one is. So we're going to have an if statement that basically is saying, if this is blank, then add 1 to a variable that is going to hold how many I've got. And so then we'll go through the whole array like so, looking to see if one of them is, or if they're blank. So let's actually have a look at the code. So it says the following code shows an algorithm to count up how many empty slots remain in the array and output this value. So we have for I equals 0 to 4. Okay, so we've got 0, 1, 2, 3, 4. So that's why we've got 0 to 4. But remember, this first line of code means nothing but do something 5 times. And now we've got to do something 5 times, and it's the things that are indented. So it says empty equals 0. If appointments I, and remember I for the first time is assigned is 0, is equal to blank, so blank string, an empty string, then empty equals empty plus 1. So we're adding 1 to this empty. And if next I. So we're going to go back up here, and we're going to be turning empty to 0 again. Now we should be looking at this and starting to think if how this is actually working. If appointments 1 is equal to blank, then and we're going to add another 1 to empty. We keep doing that until we are finished up to 4, and then we are going to print empty. But I want you to be really looking at this as well. Now, even if you haven't noticed yet, you're going to go over to here and you're going to see that it says the algorithm contains logic errors. So the first question is define the term logic error. Now, there's only 2 types of error that you need to know. It's a syntax error and a logic error. Your syntax error is literally a mistake in the grammar of the actual programming language that you're using. And as soon as you get a syntax error, your code will stop. It will break. Okay. A logic error is when we have a problem with some sort of calculation or the way something is done, so that the code will still run but not give us the result that we were expecting. And that's the 2 main differences. And so here we can say that it is it's an error that an error in the process, but it will not stop the code from running. Okay, let's just make that a little bit bigger. So really importantly to understand the difference between that logic and that syntax error. So it's an error in the code, but it doesn't stop the program from running, it just stops us from getting what the expected result was. So now it says identify the line number of 2 logic errors in the code and explain why each is an error. So I'm kind of hoping that you would have already picked up on this, and I tried to point out a little bit that every time we go into the next iteration, our variable called empty gets set to 0. And what we actually want to do is we want empty to be counting every single time and adding to it each time. But what we're doing here is, because empty is inside the for loop, it's getting set to 0 at the beginning each time, every single time we iterate. So this empty, line 2, actually should be before the actual for loop has started. And so what we're saying here is, which line is it? So 0, 2 is the incorrect line. You could say line 2 empty equals 0. That's where the problem is, okay? I might actually write line 2. And then what you need to do here is you need to explain why. And so what you could say is it will reset the variable empty, variable empty to 0 at each iteration, i.e. each time it loops through, okay? Now, you don't need to say what it needs to do. It hasn't said fix it, but if you were to fix it, you would be saying that actually empty needs to be before the for I equals. So empty needs to be on line 1 as it's first. Basically, you're declaring the empty variable so that it can be used in this for loop. Okay, so logic error 2, I'm hoping also that you noticed down here. What we're doing here is on line 7, we're printing, but you'll see that empty is in speech marks. And so what you're going to do is you're just going to print the word empty, or the string empty, rather than the number or the value that is held in empty. So again, I'm going to write line 7, and I'm going to write print empty. So I'm saying what the problem is. I think you'd get away with literally just writing line 7. And here we'll output the string empty instead of the value held in the variable empty. So I hope that makes sense. Neither of them will have stopped or broken the code. So both of them are logic errors. They are both errors in our logic of how we've worked this piece of code. And so sometimes I think people might look at this as being a syntax error. It's not. It's syntactically correct, but the logic behind it is incorrect in that we wanted to print the value, not the string. And so the program will not stop running. It's just not giving me an output that I'm expecting. So that is question B completed. I hope that made sense. Right, let's have a look at this one. Okay, so here's one of our sort all searches, and this is something you really do need to make sure you feel comfortable with. There will always be either 1 or 2 sort and or searches. Let's read the question. Each teacher has the assessment grades for each student. These grades are stored in numerical order. The grades for one student are shown. So we've got 2, 3, 4, 5, 6, 7, 8. Show the steps that a binary search would take to check whether the student has achieved a grade 7 in any assessment. Your answer must refer to the grades provided. So basically what we're doing here is they're saying show the steps that a binary search. This is show the stages of a binary search using this data. Okay, so the first thing is we need to find the middle item. So find the middle item. This is 5. Okay, so you can see the middle item is 5. Compare the middle item to the item searched for. So we can then see that 5 is smaller than, and the item we're searching for is 7. So remember with the binary search, it's the idea of this divide and conquer. Divide and conquer basically means at each iteration we go through it, we split up, we half the amount of things we're looking for. So 5 is smaller than 7, so we remove all items smaller than 5, because we know for a fact, because it's in order, because these are put in order, if 5 is smaller than the number we're looking for, then clearly everything to the left, or everything smaller than 5, is also smaller than 7. So let's say discard or remove all items smaller, and then we can say to the left of 5. You could say including 5, because we know that 5 is not it, so the left of 5, and then we could say including 5 as well. Okay, so we've now got 6, 7 and 8. So 6, 7, 8, and now left. If you wanted to, you could put it like this, so you're showing kind of like that it's in an array, but you don't have to. 6, 7, 8 are the new array, and basically repeat the process. Find the middle item. This is 7. Compare the middle item to the item searched for, and 7 is equal to 7, and therefore the item is found. And I suppose we could say, and the search stops, because we have found, in fact, that this student has found or has achieved a 7. But 7 is equal to 7, and therefore the item is found. Search is stopped. Okay, so there's 4 marks here, so probably they're looking for at least for you to talk about the middle item, comparing the middle item, and then that idea of knowing, because the all of the data is in order, in numerical order in this case, but if it was string it would be in alphabetical order, that if the item the middle item is smaller than the item you're looking for, then you get rid of everything smaller than that. Or if the item you are looking for, if the middle item is bigger than the item you're looking for, then you get rid of everything bigger than the middle item. So it's that the binary search is about looking at the middle item, comparing it, and then discarding the ones that just won't ever fit in. So that's a really important one to remember. Don't forget, so there's 2 searches that you need to know about. So this one's the binary search. The linear search is literally looking at the first item and comparing it for what we're looking for, then the next, then the next, then the next. So remember, linear just goes along the line. Okay, remember, linear line. Okay, so let's have a look at the next question. Explain how a binary search would determine that a value does not appear in a given array. Now, if we were to look at this one again, and let's say we were looking for, the number 9, which we know is not in there. So when we got to having 6, 7, and 8 as the new array, we'd look at 7 being the middle item. We'd compare it, and if it wasn't, and 9 is larger than 7, so we would get rid of 7 and everything lower than it, and so we would then only have the 8 left. And so we would then compare that final item, and we would see that that is not the 9 that we're looking for, so therefore we know that it is not in this array, or in this list. So the important thing is we know that we go to one data item. Okay, let's just write this in here. So we when the list is down to only one item, the item in the list is compared to the search item. If this is not equal to, I was going to write the same as, but if this is not equal to the search item, then we can say that the search item is not in the list. Then we can say that the search item is not in the list, or was never in the list. Because if we get down to that very final item and we're still not matching it with the search item, we know then that the value does not appear in the given array. Okay. And then it says, give one advantage of a binary search over a linear search. So remember the linear search, we look at one item, then the next, then the next, then the next, then the next. So if you got the other way round, an advantage of linear over binary, you could say that the data items do not have to be in order. But this one is asking you to give an advantage of the binary search over the linear search. So what we actually can say here is the binary search, because it is this idea of divide and conquer, it basically looks at an item, and as soon as it's gone through that first process, it's already it can get rid of half of the items in that array. So it is more efficient. We know that it doesn't have to look through every single item. If you think about the worst case of a linear, it has to look at every single item or compare every single item to the very, very last one. So it's more efficient. I think we should say especially on large lists. And I think that would be absolutely perfect to be able to say in there. Okay. All right, so we're now on question 3. So we've moved away from the search questions now, and we're on a completely new one. And it says, a cinema uses the following criteria to decide if a customer is allowed to see a film that has a 15 rating. Customers have to be 15 years of age or older to see the film. They also need to either have a ticket or have the money to buy a ticket. Now, everything in these two sentences here gives us absolutely all the information we need, and we must be reading it very clearly. So please, again, take your time over this. The table shows the inputs to the system that will output whether the customer can watch the film. So we've got input A. So A is if we have the customer as being 15 or over. B is the customer has a ticket. And C is the customer has the money to buy the ticket. And it says draw the system using logic gates. It might say draw a logic circuit. For this type of question, it's the same thing. Using the logic gates is drawing your logic circuit. Now, you won't be given, in this one here, you have not been given the logic gates. That's why I've just got this here, because it's quite difficult for me to do it on the computer quickly while I'm showing you. So I've decided to put my logic gates just here, okay, and I've also got my inputs A, B and C, and I've also got my output, which is basically saying if it's true, then it will be see the film. You can go and see the film if you get a true entry. Okay, so it's important to read this. Customers have to be 15 years of age or older to see the film. They also need to either have a ticket or have the money to buy a ticket. So what we've got to look at here is it's basically saying we've got an OR gate going on here. So they need to have a ticket or have the money to buy a ticket. But no matter what the result of this one is, they have to be 15 years of age or older. So I'm going to put the OR gate down here, and I hope you're remembering your OR gates and AND gates. So we've got AND, OR, and NOT, okay? And just so happens we're not going to need to use the NOT in this case. And we're going to say B here. So B, remember, is the customer has a ticket, or C, the customer has the money to buy a ticket. So either or, as long as one of these is true, then the result of this is going to be true. And this is really important to get our heads around, because then it says customers have to be 15 years of age or older to see the film. That's non-negotiable. And so the AND gate actually comes after that OR gate. I'm just going to make it a little bit bigger here. Okay. So no matter what, we need the students to have, the customer to either have a ticket or not. Sorry, have a ticket or the money to buy the ticket. And as long as that is on, then we have, and they have to be over 15 to be able to see the film. Okay, so no matter what the result of this one is, as long as one of these is true, we will get a true here. But both of these need to be true for us to get a true to be able to see the film. So the customer has a ticket, or the customer has the money to buy a ticket. If that is true, we have the result of that, and then both of these need to be true. The result of this and A, with the customer is 15 or over, both of these need to be on or true to be able to be true to see the film. Right, let's have a look at the next question. Now, because I was actually running out of space a little bit, I have re-put the question here, the information page here. Okay, so it says complete the following algorithm to output whether the customer is allowed to see the film or not. So this is really important. We've got to understand that we can turn these logic gates into quite a simple algorithm. Okay, so what we're looking for here is we've been given the inputs. So A equals input is the customer 15 or over. We're either going to have a yes or a no or a true or false. Again with B, does the customer have a ticket? Yes or no, true or false. And then C, does the customer have money to buy a ticket? That's going to be a yes or a no or true or false. So I'm going to say that we're going to receive a yes or a no. Okay. And once we've asked those, we've got those inputs, we can now use an if statement. If A is equal to, and we're going to just say yes. If A is equal to yes. If you wrote if A is equal to true, that's also fine. But what we need to do here is A needs to be yes, and then to make it a little bit easier to understand, because we need to check B or C first, we put it in brackets, and we say and then we go B is equal to yes, or C is equal to yes. Okay, so what we're saying here is these two, we need to check this first because they're in brackets. So it's basically, what is the result of this? B needs to be yes or C needs to be yes, and one of those needs to be yes and A needs to be yes for us too. And so what you can now do, don't forget to use your to write indents when you're writing code, and we can say print, and we can say you can see the film, or you're allowed to see the film. It does say here whether the customer is allowed to see the film or not, and so we could actually say allowed to see the film if that is true, but then we need to say else, and then if any of that doesn't work, then print, and then we say not allowed to see the film. And that's it. You can do your end if here. If you don't write the end if, that is not the end of the world, but this is kind of like your OCR language. Okay, let's move on. Now it says the cinema has 3 screens, red, black and yellow. It says the function free seats counts how many seats are available in each screen. The name of the screen is passed in as a string parameter, and the number of free seats is returned as an integer. Write code using the function free seats to find the number of seats available in screen red and assign this to a variable with the identifier red seats. Now, there's a lot going on in here, okay? They're giving us the names of the screens, red, black and yellow. They've given us a name of a subprogram, and that subprogram is a function. So that means that it returns, when we send data to it, it does some sort of calculation, and then it returns that data to us. What we have to remember is that whatever it's doing is kind of abstracted from us. We don't need to know how, at the moment, how this free seats function works. We just know that we call it, we send some data to it, it runs through its calculations, its own code, and then it will return data to us. Okay, so from our main program, if we're calling it, we need to assign the result of whatever is returned from this free seats function to a variable, and they've actually told us what that variable name is. They've said here assign it to the identifier red seats. Okay, so there's quite a lot going on here, and we've really got to read this through. So what they're asking us to do is just in our main program, but they're not asking us to write anything more in the main program, so don't overcomplicate it. We've got a variable that they've said that needs to hold the result of whatever is returned when we send something through to the free seats function. So we're saying red seats equals, and we're going to now, it's assigning that data to that red seats, and it's when we call the free seats function, and it says here the name of the screen is passed in as a string parameter, and they have given us the name of the screens here. They've specifically told us to look for red, and we're going to be assigning it to the variable red seats. So remember, it's a string, and you can see that it's a capital R, so we must be careful, make sure we get that absolutely accurate. So what we're saying here is I want to send the word red, or the string red, through to the free seats function. The free seats function will then do its own calculations, and it will be looking to calculate how many, it says here, it counts how many seats are available in that screen, but then it needs to return, so you've returned as an integer, so the number of free seats is returned as an integer, so therefore it needs to, once it's finished doing that calculation, it will find a number. Let's say it's got 10 free seats left in the red cinema, and so that number 10 then needs to be assigned to the red seats identifier, because they asked us to do red seats. And so the number 10 will be returned to red seats. Red seats is now holding the value 10, and we'd be able to use that in the rest of our code to see to say that we've got 10 seats available in the red cinema. Right, let's move on. A car dealership uses a computer system to record details of the cars that it has for sale. Each car has a make, a model, age, and number of miles driven. Each car is given a star rating of 1 to 5 based on the age of the car and the number of miles it has been driven. This rating is recorded in the computer system. So the first thing it asks us to do is a little bit of definition, a little bit of terminology, and it says define the term abstraction. So there's really, this is your computational thinking, and there's only two terms they're probably going to ask you about, which is abstraction or decomposition. So remember, decomposition is the breaking down of problems into smaller, more manageable chunks, and abstraction is removing unnecessary detail, okay? Or you could say simplifying the problem. You could say just removing detail. Let's just say removing detail that is not needed. Let's say that, okay? So, and don't forget, sometimes you need to specifically say it's focusing on just the detail that is needed. So there's two ways of going about this. You can say either removing the detail that is not needed or focusing on the detail that is needed. Give one example of how abstraction has been used in the design of this star rating. Well, you'll see here, each car is given a star rating of 1 to 5 based on the age of the car and the number of miles. The rating is recorded. It says give one example of how abstraction has been used in the design of this star rating system. Well, it's only using the age or the number of miles of the car, and so we know that it's only focusing on specific details, so age and number of miles, or it's not focusing, or it's removed any detail about the make, the model, and you could say the colour, anything like that, but I would probably stick to the information they've given us. And so we could say only focusing on age and number of miles, removing details like, and you could say make or model or so on. Okay, so remember that they're always going to try and give you the hints in the information. That's why it's so important to keep going back to that information. Now it says, explain how authentication could be used as part of the defensive design considerations for this computer system. So first of all, because it's an explain question, we want to say really kind of what we know what authentication means. And really what you've got to remember, authentication, you do this every single time you log onto a computer or you get onto your own smartphone, and it's basically checking that you are the person you say you are. Okay, so it ensures that the user is the person that should be accessing the system. So it ensures the user is the person who should be accessing the system. Okay, that's what authentication is, but it is saying sort of like explain it. So how could we ensure it? How can we ensure it's a person who, how can we ensure it is you that's accessing it and not someone trying to access it on your behalf, like unauthorized access? And so we could then say using a username and password to check this. Okay, so there's your 2 marks telling us what authentication is and then also what we could do to use this. Okay, so the car dealership only sells cars that have fewer than 10,000 miles and are 5 years old or less. Write an algorithm that will ask the user to enter the number of miles and the age of the car, validate the input to check that only sensible values that are in the given range are entered, and then output true if valid data has been entered or false if invalid data has been entered. There's a few things going on here. Number 1, we've got the first point asking us to get the user to enter some data. Now they've put this in 1 bullet point, but they're asking for the number of miles and the age of the car. So it's very important that these are in 2 separate variables and they need to be meaningful names. They need to have meaningful names. So that's the first part. And what I would suggest is, at this stage, you need to be thinking, okay, well, if it's asking me to do that, as a minimum, that's what I want you to do. So miles equals input. So remember, we're asking the user to input some data, which is going to be assigned to this variable name here. And so we need to prompt what it is we want them to say. So, I don't know, enter the number of miles. Remember, you don't have to be all asking them nicely and saying, please, could you do this? Enter the number of miles. Okay. That's absolutely fine there. And then the next one is the age of the car, so a meaningful variable name, age. And again, we're going to input, and we're going to ask the user to enter the age of the car. Okay, so we've got that first part done, and that would be worth 1 mark out of this 5. So the next part is validate the input to check that only sensible values that are in the given range are entered. So again, we've got to keep referring to what it is that we've been asked to do, and we've got to think about what the input we've had. Now they've only used input as a singular there, but we know that we've had 2 inputs, and actually both of these inputs do fall within, like, you can have a range. So we're actually being asked to do a range check here. Now it says here, output true if valid data has been entered, or false if invalid data has been entered. So really what we want to look for is, we want to basically see if there has been any valid or invalid data. So I'm going to say valid equals true. Okay. Now I'm only doing this because I'm basically going to start off by saying valid is true, and then if any of the inputs are invalid, I'm going to change valid to false. Okay, so it's an if statement. It's relatively simple, and we need to do an if statement on miles and then on age. We've been told specifically that the car has to have fewer than 10,000 miles. Okay, and we know that cars cannot have less than 0 miles. So we need to say here, if miles is less than 0, okay, which we know is invalid, okay, or miles, be careful not to say and, you can't have and here, but if miles is less than 0 or miles is, and it's very important to get this right, they've said here that it has to have fewer than 10,000 miles, and so if it's less than or equal to greater than or equal to 10,000, then, and here we're going to change our valid to be false. So what we're saying here is this is declaring the variable called valid first of all, and we're just going to hold true in it for the time being, but we're then checking to see if the user has input something which is not within the given range. If it's less than 0 or, and then greater than or equal to 10,000, i.e. it has to be fewer than 10,000, less than 10,000. So valid equals false. Then what we need to do is we need to say, okay, that's fine. If it passes that test, then we need to do an else if, and we need to see about the age. So if the age is less than 0, again, age can't be less than 0, and again, our given range, and it says they are 5 years old or less. So, or age, and then is greater than. This is basically, I was trying to turn it into, we're looking to see if it is invalid. So if it is greater than 5, we are accepting cars that are 5. So it's not greater than or equal to, it's greater than 5. Then, and again, if they do that, then we're going to change our valid to be equal to false again. We're going to end the if statement. And then the final thing is we need to print out if it what is now being held invalid. And so we can actually just literally say print whatever is held in that variable valid. We set valid to true at the very beginning, and so if it jumped through this and it wasn't within these conditions, it would jump to the next one, and if it wasn't within these conditions, it would jump straight out and still be true. However, if it didn't make these criteria, if it was less than 0 or greater than or equal to 10,000, it would be turned to false, and therefore it would be printing false. And there's our output: true if the valid data has been entered, or false if invalid data has been entered. There are different ways of going around this. You could have done it differently, but the idea there is there's obviously selection going on there. We've got 2 individual inputs there, and also you must be thinking about this range check. They've given you some information here. Please try and read that information and think about, if it ever talks about valid, it's going to talk about a range check, a length check, or a presence check, most likely. So if you ever look anything about valid, think about any of those checks, the validation checks, and you should be able to then write a piece of code that's relatively simple. So let's move on. So it says here the validation routine from part BI must be tested with normal, erroneous and boundary test data. Identify suitable test data for each type of test. So we've got the normal, we've got erroneous, and we've got boundary. So let's just remember what this is. Normal basically means it is valid, it is within range, and it lets me get through. Erroneous means it is completely invalid. Now, in this case, it could be completely out of range, or it could be completely the wrong data type. Erroneous could be completely the wrong data type. And then boundary is when it is absolutely on that absolute boundary line, but is still correct. Okay, so normal amount of miles, well, we can take anything between 0 and just fewer than 10,000. So I'm just going to put 4,000 here. Okay, and normal age is anything between new, so 0, and 5, and you are allowed to have a car which is 5, but remember 5 is the boundary. And so what I'm going to say is I'm going to have a 3-year-old. So I've tried to kind of keep it sort of like middle ground. That is absolutely normal, valid data that would get through my system. Remember, erroneous is completely and utterly not going to get through. It's far too big. So you could say, I don't know, 13,000 miles. Or you could have said, you could have put in a string here. And then the age, again, we want to say that the age is far too old to be able to get through my system. And then here on the boundary, we've got to really think about what makes it an absolute. On the boundary, it's still within the miles. And so I'm going to say 9,999, because that absolutely is that basic. If it's got to be fewer than 10,000, and that's the absolute boundary number for that. And then with age, the absolute boundary number was 5 for it still to be valid. And that would be your test data, your suitable test data, to check if your system is in fact working. What you're looking for there, you're using this to look for logic errors, like errors in your logic of coding. And then it says, identify when iterative testing is performed. Well, iterative testing is another word for saying testing during development. And so iterative testing is done during development. Whilst you're developing your code, you're going to test it at each iteration. Whilst you're coding it, you're going to keep on testing it each time to check. So you can say during development, or whilst you're writing the program code, or so on. The other type of testing is final testing, which is when you've absolutely finished your writing your code, and that's when you need to actually check the final thing. Does it do what I wanted it to do? Does it do what the client wanted to do? So obviously you'd have success criteria and you check, does it meet the success criteria? Is it successful? Iterative testing is testing whilst you're developing it as you're going. Right, so we're still on the car dealership. So the car dealership sells electric cars which require charging before they can be driven. Charging the battery by 1% takes 10 minutes. For example, a battery has 80% charge. It would take 200 minutes or 3 hours and 20 minutes to charge to 100%. So it says write an algorithm that, so it says here, asks the user for the current battery charge percentage. It outputs full for a battery currently at 100%. And then it calculates how long this battery would take to charge. So that's only if it's not 100%. And then outputs this in hours and minutes. Okay, so we find out how many minutes it would be, and then we need to then convert that to hours and minutes. Okay, so let's take this one step at a time. Ask the user for the current battery charge in percentage. So we're going to call it current charge. Okay. And again, all I'm doing is I'm choosing a meaningful variable name. So current charge equals, and I'm asking the user for an input, and what is the current charge? Okay. So we're asking the user, what is the current charge? They will put in whatever that percentage is, just as an integer, and that will be then held in the variable called current charge. It then says we want to output full, just the string full, if the battery is currently at 100%. So if whatever is held in current charge is equal to 100. Now remember, you do not write the percentage sign here. It is an integer that we've taken here. So if current charge is equal to 100, then, and we just want to output, so print, and they've asked us to print full. So do always keep checking what it is like they want you to output if they specifically told you. So current charge equals input, what is the current charge? And then we're just very quickly checking if current charge is equal to 100, then print full. What we want to then do, we'll only do the next bit of code if it's not full. So this will be then else. Okay, so we'll say if it is, do this, else do this. So all of the next lines of code need to be indented inside here. And so what we now need to do is we need to use this information here to calculate how long it's going to take. So it's basically we're trying to find out time, okay, and we're basically saying we want to find out how much we've got left to charge, or how much we need to charge. So it's basically, if you think about it, we need to say, I might say time left actually. I know charge, I'm going to call it charge needed, okay? So I'm going to say charge needed equals, so if we say 100, which is if it was at the absolute top, 100 minus what current charge is, I'm going to now know how much I've got left. So that will be like, if it's at 80%, I've got 20% left, okay? So what I then need to do is I need to say what time is, and time is going to be what my charge needed, okay? So charge needed, and it's every 1% takes 10 minutes. And so actually charge needed, if I had, in the example here, if they'd written 80%, so current charge was 80, so 100 minus 80 is 20. So my charge needed is holding 20, and it takes 10 minutes for every 1%. And so we're going to say this is my 20% here multiplied by that 10 minutes. So 10 minutes for every percent of charge that is needed. What I'm then holding in time is going to be that 20 times 10, which is 200. And always do, if they give you an example, try working with that example. It makes it a lot easier for you to kind of logically work through this. So I'm now holding the 200 in time, and I want to turn it into 3 hours and 20 minutes. And this is where we use our arithmetic operators mod and div. Remember, div returns the quotient from a division, and mod returns the remainder. So whenever we're working with time, we know that, especially if we're working in minutes, we know that there are 60 minutes in 1 hour. And so what I can do is I can say the hours equals time div, so I'm going to find the whole when I divide it by 60. So 200 divided by 60, and what's the quotient on that? Well, basically, how many times does 60 go into 200? So 6, 12, 18, and that comes up with 3. And you'll see there's that 3 hours. So time div 60, I'm just returning the quotient, or the whole number, the integer from that, and therefore I'm going to have 3 held in hour. And then in minutes, I'm going to have time mod 60. What this is going to do is 200 divided by 60. What's remaining once I've put 60 into 200 as many times as I can. And so if you think about it, again, 6, 12, 18, that's 180, and therefore 20 is remaining. And you'll see here in the example, 3, and then we've got 20. So the only final thing we need to do is print, and then we're going to just print our hours and minutes. What I'm just looking for here, it says it outputs this in hours and minutes. It doesn't necessarily here say that you have to put it in a meaningful string, but if you're not too sure, then I'd probably put a little bit of string concatenation here, and I might say there are, and don't forget, so string there are plus, and then I'm going to say that would be holding the 3 hours. I'm just going to put that little space there, look, and we need to know how many minutes. So left to charge. Okay, there are 3 hours and 20 minutes left to charge. Okay, it doesn't necessarily tell you to write it like that, but if in doubt, I would, so that you can show that string concatenation. It might be worth one of the marks. I don't actually think it was in this one, but it might just be worth it. Once we've finished there, we've actually done everything they've asked us to do. Ask the user for their current charge, say full if it's at 100, so print full, else, and then what we've done here is we've calculated it and we've used the information they've given us here to slowly work through. Remember, this is just logical ways of doing things. It's really important to get used to remembering div and mod, especially when it's about time. Quite often we see it, so 60 being an hour, so 60 minutes in an hour. Sometimes it's 15 because that's a quarter of an hour. So if you're looking for how many quarters of an hour, or maybe 30 if it was how many 30 minutes there were, half hours there were. And we also often see the mod 2 come into play, because whenever anything is calculated mod 2, when the result is 0, then the number is even, and when the result is 1, the number is odd, and it can only be a 1 or a 0. So when you divide by 2, the remainder is only ever going to be 1 or a 0, and therefore you can calculate odd and even numbers, and that does come up in this exam quite often. Right, so let's move on. Okay, so we're now on section B. They've broken this paper up into section A and B, and they've said here we advise you to spend at least 40 minutes on this section. I think it's just a way of being able to give you an idea of where you are in the exam. But if I'm honest, it's quite nice as well to kind of give you sort of like that timing as well. So what we've got here, question 5, OCR Tech is an online shop that sells electronics such as TVs and game consoles. Items for sale are stored in the database table TBL stock. That TBL stands for table. It's often written like that in databases, and it's just basically saying this is a table and it's called stock, but that is the name of the table, TBL stock. And then it says an extract of this table is shown. It's really important to sometimes just to sort of like get to know what the data is in that table. So just have a look at it. So you've got item codes, you've got the item names, you've got the prices, and then you've got how many are in stock. Okay, so what we've got here is tick one box in each section to identify the correct SQL statement, to select the item code and item name for all items that have a price of £60 or over. Okay, so what you should be looking at there straight away, as soon as it starts talking about something or over, like you're looking at this and going, this would be greater than or equal to 60. Because it's including 60. Now, you might not in your exam get given these different choices. It might just say to you, write the SQL. Now, what you've got to remember is it has to always be in this order. Select, from, where. Select is select these fields that you want to return. From is what is the name of the table that you want to look for the data in, and the where is your condition, so what you're actually looking for, so that would be that price. Okay, it just so happens they've actually given it to you a little bit here, and we have been told, so we want to select the item code and item name. Okay, so we only want item code and item name for all items that are £60 or over. So select item code, comma, item name. We don't put ands, we don't put ampersands, it's always comma separated. Remember, if it wanted us to bring all 4 columns back, we would say select star. Select star basically says bring all the columns back, but it's asking us specifically only to bring the fields item code and item name, and so therefore it's comma separated. Now again, I'm going to put an X in here. Obviously it says put a tick in there. It's difficult for me to do that on the computer, but again, if you did put an X in there, it's not the end of the world as long as you get the right one. Okay, so we've already talked a little bit about the name of this table, and so it says from, and it's from the name of the table, and so this one should be the more obvious one. It's from table stock. That is the name of the table. Okay, and then we've got our where. Here's our condition, and this is where you really need to make sure you understand your greater than and less than's the right way round, but also that this is £60 or over. So price is greater than or equal to 60, and you'll see here where price greater than or equal 260, and we're going to put the X in there. So they're testing to see that you've really checked exactly what the condition is. So please do always check it and look at it again before writing it down. Do not rush these questions. Okay, so now we've got a flowchart. The following flowchart shows an algorithm to calculate the price of an item during a sale period. So again, when you get anything like this, read it, look at it, don't just jump straight to the question. So we've got start, we've got input price from user, and then we've got here price greater than 200. If the price is greater than 200, we go down here to yes, and reduce the price by, and we're not working in percentages here, we're literally just working in numbers. So if it's 200, reduce it by, if it's greater than 200, reduce it by 40. Okay, if it's not greater than 200, which by the way, remember that could mean 200 itself, then we have to ask another question: is the price greater than 100? If yes, we're going to reduce it by 20 this time, and if not, well, they just don't get a reduction. So then we just output the price from here. So all three then do lead into output in the price. Remember, this would be print price in this if we're writing this in code. So what we've got here is we've then got another test plan, and we are looking again at the different types of data when we're testing, and it's checking to see, have we got our logic right? We're looking here for logic errors. So if the price input was 50, we know that this is a normal piece of data, as in it's within range, it's not a silly, it's not completely out of range. But it's not the wrong data type or so on. But what they're actually asking you to do here is to be able to read through the flowchart and actually know what the expected output would be. So if it was 50, then we actually walk through the flowchart. Is it greater than 200? No. Is it greater than 100? No. So we go down here and we're outputting, and we haven't made any changes to price. And so in this case, we are outputting 50. Nothing has changed to that price. So the next one, 100. This is on the boundary. It's one of those pieces of data where, again, really importantly, we would be checking that we've got our logic right here if we were testing the logic in our code. So again, so the input price is 100. Is it greater than 200? No. Is it greater than 100? No. It's on that boundary. It's not greater than 100. So we go through the no again, and again, nothing has changed with price. And so again, nothing changed. So we just put what that price was in. Next one, 150. So is it greater than 200? No. Is it greater than 100? Yes, it is. So we reduce it by 20. Now this is just whole numbers. It's not saying 0.0 or any percentages here. So you're literally just taking £20 off the 150. And so therefore this is now 130 because we're going to output once we've changed that price. And so now we've got 130. Next one again is on that boundary. So input price is 200. Is the price greater than 200? No, it's not. It is 200. So it's really important. They will always test you on your knowledge and looking to see if you understand the greater than or the greater than or equals to. Very important to be always checking those. So is it greater than 100? Yes, 200 is greater than 100. So we're reducing it by 20 again. And so this time it's 180. So 200 minus 20 is 180. And then finally we're going to put 250 through. The price is now greater than 200, therefore we're reducing it by 40, and so 250 minus 40 is 210, and that will be what's output. So that question there, I think probably should be relatively simple, as long as you carefully read it and you take your time. Please do not rush these questions. Okay, next question. Rewrite the algorithm from part B, and it says you must use either OCR exam reference language or a high-level programming language that you have studied. So you guys would be writing Python here. I'm going to write it in the OCR exam language. The reason I'm doing that is because that's what all of their questions will be when they're asking you, and so I want you to get used to seeing it. But remember that you can write it in Python. So let's have a look back at it, and it basically says here, so we're going to start, and the first thing it starts at is we're asking the user to input the price. Now remember, this is written in a kind of pseudocode. This is not a high-level language. This is very much just sort of like an Englishy way of writing it. So you must make sure that you read this properly and think it through. And also have a look at the variable name. The variable name is price, and it's using a capital P. And I want you to really try to make sure you do everything as similar to them as possible. So price equals input, enter price. Okay, so that's that first line of code. Now it says here, we're looking now to do this. Now this is selection. Whenever we see a flowchart, if we see the diamond, which is the decision symbol, only if we see the diamond and the flow going back up, that will be iteration. But when it's just flowing down and it's just following different routes down, then we know that these are different pathways or selection. These are if else statements. Okay, so what we want to do here is we're looking at the first one. We say, is price greater than 200? And so we know that it's an if statement. So if, remember to write your variable name correctly. And if price greater than 200, remember it's not greater than or equal to. Then, if price is greater than 200, then, and it just literally is reducing that price by 40. Again, remember, this is all pseudocode. We need to actually write it in actual kind of coding language or coding style. So price is now equal to price minus 40. So if it is greater than 200, then we're going to reduce price to price minus 40. What we then need to do is we need to have a look at the next one. It's an else if here, because now we're looking to see if price is greater than 100. So if it's not greater than 200, then we're looking to see if it's greater than 100. So else if price greater than, and remember, not greater than or equal to. So if else if price is greater than 100, again what we're going to do is we're going to change price to equal price minus, and do keep checking it. Do not just try and remember it. So reducing it by 20. Okay, and then what we can do here is we can just, if you wanted to, you could say else if price equals price, or you can just say end if. If it's not greater than 200 and not greater than 100, then we're not doing anything to price. So you can just stop here. And then finally, we want to output that final price like so. Remember, this is a variable, and therefore you are not putting that into speech marks. This one here is worth 6 marks, so it's really important. Take it slow and keep checking as you go. And actually, you might want to just double check it again, but actually I'm really happy with that. Again, if you've got a little bit of time, you might even want to just go, let me just use some of this test table data just to check that that actually does work for my code as well. Right, next question. An item is classified as in demand if OCR Tech have between 5 and 25 inclusive in stock. A program is written that allows the user to input the current stock level and output whether the item is in demand or not. Okay, so it says here if they're between 5 and 25 in stock, but it says inclusive. What that basically means is that it is greater than or equal to 5 and stock is less than or equal to 25. And again, it's very important to, when you're given this information, just in your head already, they're giving you information that you are going to need to think about later on. So they're actually given us some code. A program is written that allows the user to input the current stock level and output whether the item is in demand or not. So we've got stock level equals input, enter the stock level. If stock level greater than or equal to 5, happy with that, or equal to less than 25, then straight away we should be trying to note a few problems here, okay, because I've just seen something there. And then it says print not in demand, else print in demand. I've seen quite a few problems there. And then it says here the program contains syntax and logic errors. Refine the program to correct the errors and write the refined version of the program. Now, when you get a question like this, they're not asking you to completely and utterly make up a whole new program. They're saying refine it. They're saying just make small changes to it, just fix it. So be really careful here that you don't think that they're just expecting you to come up with something brand new. A lot of this is correct. There's just a few syntax and logic errors. So what we're going to do is we're going to rewrite it. So we're going to say again, stock level equals input, and we're asking the user to enter the stock level. Okay. Then we've got if stock level is greater than or equal to 5, which is here between 5 and 25 inclusive. So if stock level is greater than or equal to 5, or, and then this is really important because we can see here that it's got, first of all, we've got a syntax error. This is not how you write less than or equal to. They've got it the wrong way round. It's very important. Always try and say it in your head out loud. So less than or equal to, greater than or equal to, so that you put them in the right order. But not only that, whenever you're in an if statement and you're looking at two separate conditions, you have to write the full condition. So this is one condition, stock level greater than or equal to 5. And the next condition is stock level, and this time is less than or equal to. So there's a few things. I've added stock level, which they didn't add, and I've corrected the less than or equal to because they wrote that wrong as well. Okay, so be really careful. They are quite nuanced little mistakes here. Okay, so then we're going to say print, and it says if the stock level is greater than or equal to 5, or stock level is less than or equal to 25. If they are between 5 and 25, which is what this is looking for, then they are in demand. So first of all, they've got this the wrong way round, which is your logic error. But second of all, they've got another logic error in that, well, it's actually a syntax error because we don't have a variable called not in demand. There's no such thing. So we need to make that a string. The same with in demand. And so actually we need to make sure we say in demand, because if stock level is greater than or equal to 5 or stock level is less than or equal to 25, then it's actually in demand. Okay? And then we say else, and again making sure that we get those speech marks, not in demand. And then we can end if, and we've made all of the corrections to it. So what we've done here is we've refined it. We've corrected the errors and written the refined version. Please don't overcomplicate this. The most part is correct. You've just fixed some of the errors in that program. Okay, moving on to the next question. Right. Customers can use a discount code to reduce the price of their purchase. Valid discount codes and their value in pounds are stored in a global two-dimensional 2D array with the identifier discount. The following table shows part of this 2D array. Now, this is where it's so important to look at the example. If you remember, usually in code we would do the rows first and then the columns, but there's no right or wrong. You could do either way. what you have to do is you have to look to see what their example is. So they've written here, for example, discount 2,0 holds the discount code BGF2. So you can see here they are going down the columns for the first number and then down the rows for the first number and then along the columns for the second number. And they've also then said, just to double check, and discount 2,1 holds a discount of 15. So 2,1. So we're doing rows, then columns. So that's really important to remember. It then says here, a function searches through the 2D array and applies the discount to the price. The price and discount code are passed in as parameters. Okay, these are all terms that you must be familiar with, and the algorithm design is not complete, so you've got to complete this algorithm. Now, sorry, this one's here just because I ran out of space a little bit, so let's just move this out of the way a little bit until we get to it. So number one, we should be looking at this and it says it's a function, so we should be automatically thinking, okay, it does some sort of calculation and then returns a value. All functions return a value. A procedure does not return a value. So a function returns a value. It's going to run through the 2D array. It's going to apply that discount code to the price, and then it says the price and discount code are passed in as parameters. Okay, so let's have a look at this function. So complete the design for the algorithm. They have given us that first line of code, function check discount, and we are receiving price and code as parameters, and we can see that there. So the price and discount code are passed in as parameters. What we have to understand is, what is this actual program doing? So customers can use a discount code to reduce the price of their purchase. Valid discount codes and their value are stored in the 2D array that has the identifier discount. So what's happening here is a customer will be coming in and they will be purchasing an item, and then they will be presenting a code. So we are bringing in the price of that item, and then we are bringing in the code that the customer has presented. What we've then got, we're going to create a variable here. So what it's decided to do here is they're going to create a variable called new price, and they're just going to assign whatever the price is to this new price. Okay, I'm not sure really, you don't need to do that, but that's absolutely fine. They've just decided to do that, I think probably to try and make it a little bit more logical. They've then created a variable which is going to hold the length of the array discount, as in how many items are in that array called discount. But they've also said -1. So if there were 20 items in there, size would hold 20 minus 1, and therefore size would hold the number 19. Now this is important to remember, because whenever we're working with arrays, they're always 0 based index, and so therefore we wouldn't say 0 to 20, we would say 0 to 19. And that is exactly what this line of code here says. So remember, the for loop line just tells me how many times I'm doing something, and I need to say really how many times I want to do it. For x is going to equal 0 to start with, and we want x to go up to 19, let's say, if we had 20 items in the array. But it doesn't matter how many items we've got in the array, because this is going to future-proof it, as it were. We don't type in the number, we just type in that variable. And so therefore this is saying 0 to however many items are in the array -1, because we're using index numbers. So at the moment this is just saying for a certain amount of times do whatever is indented. It's this next line of code that we really need to make sure we understand. So if discount x, 0, so we know that x is our counting variable, and then they are typing in 0 here. Now let's have a look up here at our example, and they've basically said discount x, 0, x is the changing variable, so the 2 in this case would change, so 0, 1, 2, 3, but the 0 always will stay the same. And so if we look at that, what we're looking to see is, so remember 20 holds BGF2, okay, and the X is going to be changing this first number, so it will be 00, then 10, then 20, and so we're literally just looking through all of the codes. At the moment we've got nothing to do with the price, we're just looking through the column 0 and we are changing the X each time. So we're basically working through the column like so. So if discount X0, so the first X is 0, so it would be 00 is equal to, and we're looking to see if we can match the code to what the customer gave to us, and remember that is a parameter that has been passed in to our function, and so therefore we're looking to see if we're going through this column of codes, and if once we get through it, if we find one which meets the code that we've been given, then we need to do a calculation. And what we're going to do is we want to change the price, we want to add that discount. And so therefore we say new price, which is the variable we've given, which is currently holding price, but we want to change it. So the new price is going to be whatever new price is minus, and what we need to now do is, let's say it was BGF2, so we need it to get, if X is equal to 2, we then need to say X1 to find our discount. So X, remember, stays the same. When we're in here, X is going to be, let's say, 2. So if 20 is equal to BGF2, then the new price is minus the discount X1. So X just so happens, let's say, to be 2 here, but remember it's just going through, it's going to change each time we go through the iteration. But if 20 is equal to the code, then 21 is the price that we need. X is that changing variable. End if. Once we've changed the price, once we've found the code and we've changed the price, okay, it's still going to keep going through, but once it's done that, it will have changed the price. And remember, because this is a function, and this is so important, they do this quite often, look to see, because that final thing, that final line of code is to return whatever variable is holding the result of that calculation, which in this case is new price. So we're going to return new price, and that new price is going to be the data or the value that is returned to our main program that was in fact calling the check discount function in the first place. So I hope that made sense. It's quite complicated, but just try to work through it logically and hopefully that will make a bit of sense. Now let's bring this one back in play and let's have a look at what this question was. It says identify 2 variables used in this function design. Okay. What I would probably suggest is you look in here and you look to see if there's any new variables inside that have been created inside this, and there's actually a few. So I would probably suggest you always go with the ones that are like new variable names that have been created. Even though price and code are, I suppose, variable names, they're not new variable names which are used inside this function. So it is important to think about that. And so new price is a new variable. A variable used inside this function. Size is a variable used inside this function, and remember X is a counting variable that is used inside this function. So you could have any of those, so new price, size, or you could have said X. You only need 2 of them. Okay, let's have a look at this final question here. It says write a program that. Okay, so let's start by looking at what it's actually asking us to do. So ask the user for an item price and discount code. That's easy. We're just asking the user for two inputs. We use the check discount function that we've just seen to actually then calculate the price and the discount, which actually is relatively simple in the main program, because all you're doing is calling the check discount function. You don't even need to know, it's abstracted from you. You don't need to know how it works. All you're doing is calling that check discount function, and as long as you know what parameters, what data to send through to it in what order. And because it's a function, you need to assign it to a variable to receive that return value. Then that's actually relatively simple. But then it does say repeat bullet points 1 and 2 until a price of 0 is entered. So we know that actually we're going to need to iterate, okay, and it's until something happens, and therefore it's on a condition. So it's a condition controlled loop, not a count controlled loop. And what we're going to do is we're then going to output a total cost of all the items. So what it's asking here is that the user might have many items and discount codes. So they'll go through as many times until the user puts in a price of 0. So the first thing we need to do is we need to think that we're going to be calculating a total, and therefore we need to declare our total in the first place. And then we need to, we're going to do a condition controlled loop, and it's basically going to be while price is not equal to 0. But if I was to type in while price is not equal to 0, well, you can see that we've got an error here, because there's no such thing as price, and so straight away the program is going to say I can't move any further, I don't know what price is. So the important thing here is you need to declare price the first time round so that it goes through the while loop. But remember, price can't equal 0, because while price is not equal to 0, we're going to go through the while loop. So this, you could say price is equal to -1 or 1. It doesn't matter as long as you don't say price is equal to 0, but you also need to make sure that you don't put in the wrong data type. So you can't say true or false, or you can't put in a string. So I'm going to say price equals 1. And that's just so that we can get into the while loop in the first place. So while price is not equal to 0, so we are going to go through the while loop the first time. And so therefore we're going to ask our user to input the price. So price equals input, enter price. So you're prompting them to enter the price there. And then we also need them to enter the price and the discount code. So you're also going to ask them to input, enter the code. Okay, so we've done that line of code there, and we're also in the process of doing this repetition, this while loop, or this condition controlled iteration. Now use the check discount function to calculate the price of the item. Well, we've got the price and the code, so I want to find out the discounted price. Okay, discounted price is equal to, if I send my data through to the check discount, okay, and you've got to remember, let's just jump back to it, always keep looking back at the function itself so you can see it's called check discount and it's receiving price and code as the variables. Okay, that's all we need to make sure we know, that it's the variables in that order, and therefore, and it just so happens that I've called them price and code in my main program as well, so I'm going to send price and code through to it as so. So we are calling the check discount function, we are sending price and code through to it. It's going to then do those lines of code. We don't need to necessarily know how to do it, but it's going to go through all of this and it's going to come up with a calculation of this new price. That calculation of new price is going to be assigned to this variable called discounted price. So discounted price in my main program is going to hold that new price after discount. The only other thing we now need to think about is, because we're going to go through it over and over again until they put in a 0, then we need to keep on calculating our total. So total at the moment is 0, but new total is going to be equal to whatever total that is now plus the discounted price. We'll keep on doing that until the user puts 0 in as price. Okay. If they do put 0 in as price, that's fine. It's still going to go through these lines of code, but they're not going to find it, and so therefore we're going to be finished there. So we can end the while loop there, and then it outputs the total cost of all items entered after any discounts have been applied. Again, it's not asking you here to put this into a meaningful string, so you could literally just type in print total. If it says outputs the total cost in a meaningful way, then you would do string concatenation here. But I don't think they're actually looking for that here. They're looking for you. There's enough going on here for you to be looking for it. If in doubt, though, you wouldn't get marked down for doing string concatenation. And so actually I'm going to say the new price is the new total price. The new total price is plus total. You could say actually that's fine actually. And that would put it into a meaningful sentence if it asked for that. Okay, there's 6 marks there. It's a relatively complicated one. Remember, you need to read all the bullet points to really think it through. And because it was repeating, you had to think about that iteration beforehand. And you now have a finished program that works. And that is the end of the paper. Best of luck. Please ask questions if you have any.